pretty accurate too.
Okay.
Like, maybe also he's like, but if not.
Oh, I can see it. It's not a problem. Yeah, I have a good sense of that. I haven't watched it. So.
Who's talking? Oh, my God.
Do you wear glasses, Thomas?
Good. Good. All right, well, welcome everyone to our first colloquium of the year. I'm excited to introduce Dr. Kyle Pfaffenbach. I'm Jennifer Fuentes in the Sociology and Anthropology department, but today he'll be sharing some of his research with us. So he's an assistant professor in the Department of Physical Activity and Health. He has his bachelor's in exercise science, master's in nutrition and exercise science, and Ph.D. in nutrient biochemistry from Colorado State University. After he completed those degrees, he went for a postdoc fellowship at the Norris Comprehensive Cancer Center in Keck School of Medicine at the University of Southern California.
They're very particular about how you say that, so you did a good job.
I know. I've learned that since moving out here. There's a lot of particular pronunciations to be aware of. After he finished his postdoc, he and his wife moved to La Grande, where she's from originally and still has family. This is Kyle's 5th year with us here at EOU, and he mainly teaches exercise physiology and nutrition. All right, I'll turn it over to you. Thanks.
Thanks a lot, Jennifer. First of all, thank you very much for coming and taking time out of your day to hear some pontificating. So I'm going to start here. So I want to, basically I just want to share a little bit about my training before I got to EOU and how I've used that to translate sort of a basic research training into applied field research that can be used to help undergraduate students. And so I want to start with this kind of figure that I put together. This is something that when I talk, say, in the uni classes or when I have an opportunity to talk about young students about their careers, I usually describe it in this way, not as a blue box with some blobs. But what I'm trying to illustrate here is that at each sort of step in an individual's career, I kind of see it as you're sort of at a crossroads or you're at a place. When you're at the place, you have a bunch of different options, and they're all going to lead to something different. And eventually, you manage those opportunities, and you take advantage of those opportunities, and you think about those opportunities, and you end up choosing some sort of path. And as you get sort of here, it's harder to go back and decide, I want to do something like this here. So these are important decisions, but they aren't sort of the end-all, be-all. You don't just get here, and then there's no other opportunities. And so this sort of continues as you go along, and every place that you go, there's new opportunities, and you just kind of have to really sort of look for them and take advantage of them when we're there, and that's part of what I'm going to talk about. And for me, this journey has the 3 early stops were all at Colorado State. Initially, that was motivated by a desire to ski and not live in Ohio. I love Ohio, but to experience something new. But really, as you kind of see, as the farther I got along here, it really became motivated by science and what I was learning and opportunities. And then the sort of 4th stop or 3rd stop really in my formal training was at USC, and now I'm here at EOU. And I just want to share some of the opportunities I had along the way and then some of the things that we're doing here at EOU. So I'll just start with kind of stop number 1, where really my formal scientific training, and I really want to make sure that I give credit where credit's due. And these 2 gentlemen, Dr. Matt Hickey and Dr. Chris Melby, were instrumental in developing just a passion for science in me and teaching me the principles of scientific discovery and in conducting research. And they were my mentors at the master's degree level. So you'll see here in the early 2000s, these gentlemen published what is still considered a very important paper, which it was really addressing an important health disparity. So we know that non-Hispanic whites have sort of less incidence of type 2 diabetes than Mexican Americans. So Mexican Americans are at increased risk for developing type 2 diabetes. But and that is shown in the epidemiologic data, but at the time what wasn't well understood was whether or not there were physiologic differences between healthy non-type 2 diabetic Mexican Americans and non-Hispanic whites, and if those differences would have indicated whether or not there was some susceptibility to developing insulin resistance. And so they published this paper in the AJP Endo, you can see quite a few years ago. But really what this paper demonstrated was that even in young college-aged population that was matched for fitness, fatness, not just the percent body fat, but also where the fat was, because that can be a risk factor for type 2 diabetes. They demonstrated even in individuals that were matched for all these things, Mexican Americans had higher insulin resistance under those conditions. And this was really important and really set up the work that I did as a master's student. So just briefly, many of us know that diet and exercise is very important for reducing risk of type 2 diabetes or increasing insulin sensitivity. But what we didn't know is if you had healthy individuals and one group has higher insulin resistance and the other group doesn't, so they had increased risk for type 2 diabetes is what that means. If they do the same amount of exercise and if they do the same diet, would they get the same benefit? And this is a really important question because what you're asking is, do we need specific dietary and exercise recommendations based on ethnicity and background of the individual? And really, so what we were able to demonstrate is that they both got equal benefit, but there was no catch-up, if you will. So there was the disparity that existed at the beginning still existed at the end, but the markers of insulin resistance were improved. But really, I mean, that part of it's important, but in the journey and kind of what I'm talking about today, I wanted to sort of focus on some of the most important things that I got out of that stop, if you will. And really, I got the opportunity to work with human subjects, which is something I use that experience a lot here at EOU, because we do a lot of applied studies now. I was able to participate directly in research that's directly aimed at health disparities. This is the first time that I really had gotten the opportunity to sort of address differences within a population and go out and kind of speak with them and work with them in culturally appropriate and sensitive ways, and really learned a lot about kind of that aspect of things. So also got experience managing and organizing complex data sets, and most importantly, the part of that study that I did was actually analyzing muscle tissue that we took out of the subjects during different insulin sensitivity tests. It's a thing called a muscle biopsy where you put about a very large needle into a person's thigh, you take out a little piece of their muscle, and then you actually freeze that in liquid nitrogen, crush it in mortar and pestle, and then you can look at differences in protein expression and other signaling molecules. And this really sparked my interest and was my introduction to molecular biology as well as integrated physiology. And this led me to the lab of Mike Pagliasatti. He's got a lot going on. He's now the department head of the nutrition department at Colorado State. He's also an endowed chair at Colorado State. And Mike is probably the smartest, one of the smartest people I've ever met, and one of the most outstanding scientists, if not the most outstanding scientist. And he had such a passion for science, and he was really able to sort of instill that in me and search for the truth. One of my favorite stories about Mike is that we had, there was one time when we had a data set that wasn't published yet that contradicted another very well-known lab that had a data set, and they were finding different results, and we were trying to figure it out. And I was young and competitive at the time, and I said, well, let's just publish it and see what happens. Like, do it, like, let's just, do that sort of thing. And he said, well, Because in this lab, we're on the search for the truth. And if this is true and what we have is true, we need to find out where the truth lies in those. And it isn't about who's right and who's wrong. This is a search for the truth. And that was a really important lesson that I got. Now, one of the things I also wanted to point out, which always blows me away, is back in the mid-90s, Mike published a series of papers that were seminal in our understanding of how the liver metabolizes fructose different than regular sugar, and was the basis of a lot of important information that we take for granted now, like high fructose corn syrup isn't good for your liver. And so he was, now here in 2018, it's pretty common knowledge that high fructose corn syrup, but back in the mid-1990s, that was very novel, and he was instrumental in showing that it wasn't just correlation, but that there was cause there. So Mike also introduced me to this intracellular signaling pathway called the unfolded protein response, which I grew to really appreciate and care a lot about. And as much as I would like to go through all of this in great detail, I'm not going to do that. I just want to show you these are the types of things where we were manipulating cells and animals and looking at the expression of these different proteins and finding out what was happening in regards to those. This was a really productive time for me. I was able to publish 6 papers in the 3 years that I was with Mike, earning my Ph.D. And it was really a collaborative effort. You can see the number of authors and the mixture of order of these authors, and it was just I was able to participate in a lot of different techniques, gain a lot of information about molecular biology techniques, publish, synthesize, write. And probably the most important paper that I had during this time was this paper, and it was important for a couple reasons. One, it was my hypothesis, or Mike and I's hypothesis. It wasn't, a lot of times as a junior student or an up-and-coming student, it's kind of, you're sort of given the hypothesis, or you're given the direction of the lab. And it wasn't like that with Dr. Mike. Dr. Mike let us develop things, and I gave a lab presentation one morning in a lab meeting. He saw a hypothesis in it, we started developing it, and this is the work that came out of it. The other thing that was important is that, it linked the UPR to this protein called mTORC, or mammalian target of rapamycin complex 1. Again, not going to bog you down with this, but both of these things are implicated in cancer development, cancer progression, as well as cancer resistance to chemotherapy. And so getting the opportunity to study something under physiologic conditions, not cancer conditions, but to understand these intracellular signaling pathways that were cancer related really opened up a whole bunch of new opportunities for kind of the directions that I could have after getting my PhD. And that opportunity led me to the lab of Dr. Amy Lee. So one of those, the slide I showed you before about the endoplasmic reticulum stress response, or the unfolded protein response, that had all those. So Amy Lee, and I think in the early 1980s, discovered and characterized one of the most critical proteins for that entire pathway. And she's really built her career around understanding that one protein, 35, 40 years studying one protein and understanding it. But it's such an important protein in the context of so many different conditions. And she has built her career around understanding its role during cancer. So she also has a lot going on. She's a professor of biochemistry and molecular medicine. She also has an endowed chair. She's the associate director of basic research at the USC Norris Comprehensive Cancer Center at the Keck School of Medicine. So this is the medical school campus with USC is different than their what's called their University Park campus. It's a dedicated medical campus. So it's a whole separate campus that has hospitals and research facilities and a cancer center and stem cell research centers, et cetera. So it was a very kind of exciting opportunity to really grow in a lot of ways. So this was a similarly productive time for me. And the one thing I should note, or that I want to point out, is that I was at USC for just over 2 years. I was able to publish 4 papers, but it's all I was doing. all I was doing was working in the lab. All I was doing was dedicating myself to that pursuit. And it was really because of that environment. You were expected to publish papers, you were expected to produce novel research, you were expected to push things in this way. And it was a really it was a very, very intense time where I learned a lot. Yeah, it was really critical to my decision for coming to EOU too. One of the things that I'm particularly proud of during this time is that this paper down here, the critical role of GRP78, so this is that protein that Dr. Amy Lee discovered or characterized for the first time. I wrote this paper in regards to its role both in pathologic stress, meaning disease states, as well as under physiologic conditions. So how does this function just when we're operating and eating and running or recovering from exercise or different things like that? And this was published in a journal called The Current Opinion of Cell Biology. It's a journal that only comes out every other month, and it's really has articles that kind of discuss sort of the state of a particular field. And in 2016, this was rated as one of the most cited papers in Current Opinion in Cell Biology, and I think right now it's around 100, well, I know, it's 193 unique citations for just this one paper. So I was really kind of proud of that work. So in regards to when I was thinking about giving this talk and really digging into how I wanted to present this, my time at USC was really important for a couple different reasons. One, gained insight into specificity and complexity of disease states. This was an appreciation of the different types of diseases, but also that the same disease can have so many different iterations and it can affect people in so many different ways. And it really gave me an appreciation for the uniqueness of how people interact with different, I'm just going to say, stress or perturbation. And that's been really sort of principle, and those of you that have had me in class know I talk a lot about individuality and specific training and specific nutrition and those types of things. So this was really important. Also learned several really advanced molecular biology techniques. So I was able to work with transgenic mice, and one of the papers that we publish on was a mouse that we had bred specifically to be missing 2 proteins in the liver. And that was a completely novel mouse model that had never been done before. And so we were able to specifically knock out 2 different proteins in just the liver and then see how that affected those mice in their development of liver cancer, fatty liver, and these different things. So it was really exciting. And the reason why I bring those things up is because I've been able to translate that into the classroom we have 2 exercise physiology classes that we teach. One that's basic exercise physiology, that's kind of exercise from the 1970s to the 1960s to the mid-1990s. That's when exercise science started moving down to the molecular level. And this experience really gives me an opportunity to talk about more recent research and mechanistic research regarding, and it's something I get the opportunity to share with students. This was probably the best part of being at USC. It's just an incredible, high kind of powered, high paced environment with a lot of smart people. When I was kind of going through these slides with my wife last night, and I was like, do you think I should tell them about some of my lab mates? And I don't know, she thought it was relevant, so I'm throwing you under the bus if this doesn't work out. Yeah. But really, the Ph.D. students that I got to work with, and in a lot of ways mentor while I was there, were some of the smartest individuals I've ever had the pleasure of working with. And so in a lab of, I think, around 15 people, I was one of 2 Americans, and I was the only American postdoc. A lot of people most of them were from mainland China or Taiwan. And so I made some really close friendships and also developed these really interesting working relationships where I was kind of helping them to learn how to write and present and speak academically and present their data, and they were just worlds ahead of me in terms of understanding and lab techniques and these types of different things. And we were able to really share those and learn from each other. The one thing I will say is that just to put their intelligence into context, there are 9 million high school seniors that take the college entrance exam to get into college in China. Only about 40% of those 9 million get into any college. About 2% of them get into the top 5 universities that are in China. One of those, the #1 school in China, is a university called Peking University. In the molecular biology department at Peking University, they accept 3 cohorts of 50 students. So 150 out of 9 million students get into the molecular biology department. We had 3 graduates from the Peking University molecular biology department in my lab at USC while I was there. So it just kind of contextualizes that type of environment and how rich it was. So, but really some of my most fond memories and the things that motivated me the most was working with the pre-med students, the junior students, the Ph.D. students, and it really comparing that part of it to the other part of being at a Research One Institute, which is it's very, very competitive. Funding is very difficult. You really have to work in a certain way that a lot of times leaves students behind. And this was really the formative experience for me that sort of where I came to the realization that I want to be at a place where students are put first and research is a vehicle for students to achieve their goals, as opposed to research and my agenda being first and students are a vehicle to make that happen for me. It was an important moment for me in this kind of journey. So that's how I ended up at EOU. Like Jennifer said, my wife is originally from here. I didn't know what was going to happen when we moved back to LeGrand. I didn't know if I was going to end up in industry or all these types of things, but we ended up in LeGrand. And just full disclosure for those of you that might not know like where you're heading in your life, if you have a PhD and a postdoc and you're living with your in-laws in LeGrand, Oregon, at some point, it's not a hopeless situation. Right? So, and in many ways, the contrast of that to what I was going through at USC, hour and 15-minute commute one way each day, 12-hour work days, 7 days a week. It was a pretty awesome contrast. So, when I got the opportunity to be at EOU, this was like truly an ideal career opportunity because there just aren't that many places where they value teaching over everything else. So now, one of the things though about getting an opportunity in a new environment is you have to take stock of the environment. You have to take stock of the landscape that you're in and ask yourself, how am I going to be effective in this landscape, right? We were, the only time we needed sort of a sign off is if we were going to order something that was over $2,000 in the lab at USC, right? If something was over $2,000, you had to like talk to Amy Lee. Otherwise, just get what you need to get your job done, right? And so that's just one of the small differences about the environment. And so you take a look at the new landscape and you ask yourself, how am I going to be effective here? So one, I'm going to be working with undergraduate students, what I was really excited about. Two, here there's an emphasis on teaching and learning, which I've already sort of discussed. There's high contact and interaction with students, which again, I was really looking forward to. There's a responsibility that we have here to being involved in positively impacting local communities, and that's something that I was really excited about the opportunity to contribute to. One of the most important things in a high contact situation with undergraduate students is that you're giving them a chance to achieve their goals. And here you're talking about highly competitive graduate programs and highly competitive job markets. And it was something that when I was thinking about the types of projects and research and efforts that I wanted to do here, it was really focused on helping students be able to take those next steps. This was something unique I'd never heard of. I'd always been at very, very large institutions where I don't think logistically this would always be possible. But here, the fact that every student at EOU in every major is required to do a capstone project, integrating what they've learned throughout their college career, it was just like this incredible opportunity, because you have these students that are interested in applying what they've learned, and you can influence what they learn in the coursework as it leads up. And those of you, again, that have had classes with me, I always talk about, this is going to come back when we sit down to do your capstone. This is the type of equipment that you're going to be able to use when you get to your capstone. So let's take this seriously and learn about it so that we can be effective when the time comes to do your senior project. And then, of course, you have to be creative. There's limited research funds, and we do a lot with limited research funds here, and that's kind of what I'm going to talk about now. So this was the first major capstone project. Student walked into my office, Cassie went, outstanding softball player here at EOU, even better student, which says a lot because I think she has the home run record, all-time home run record. And she walked in my office and said, I like the class I'm in with you. I'd like to do a capstone project. I was like, well, what's a capstone project? I hadn't really, it was just sink or swim. They were like, you're hired. These are the classes you're teaching. It was great. So so she walks in, she says, I want to know how Red Bull energy drink can improve softball performance, right? And I hadn't taught performance nutrition yet. I'd been working with mice and cells. I hadn't been working with humans and nutrients. And of course I said, why? And she said, because I've drank, and now this, I said I wasn't going to bog people down with technical language. This just means a lot of Red Bull during my softball career here, and I want to know if it did anything. Really? And you have a choice at this point. You say, I'm not the type of person that's going to study the effects of energy drinks. Or, I said, I don't know, maybe this could be interesting. And I started looking up. It turns out there's a little bit of a body of literature, not a lot, on energy drinks and sports performance, not just caffeine and sports performance, but energy drinks and sports performance. When you start looking at the sheer volume of energy drinks that are consumed in this country alone, you know that people are utilizing them. And so I think the more you start thinking about it, you think this is a pretty decent question. How can we systematically understand this a little bit better? What are the things that would maybe be affected at the softball level by the presence or absence of a carbohydrate and caffeine drink, and how can we capture it? So we developed this study. We went to great lengths we knew we weren't going to get a lot of subjects, so we had a within subjects design. That means each subject got both conditions. But there's definitely a placebo effect, and the placebo effect is very real. So we went to great lengths to mask whether or not, to randomize whether they got the Red Bull or the placebo, and to mask basically the taste of Red Bull and whether or not they were getting it. So it's pretty gross, actually. We took diet, non-sugar soda, and we put a bunch of coffee flavoring into it, and we put some other stuff into it, and then we put it into a Nalgene bottle that was wrapped in black duct tape. Then we put a nose clip on it. The people had to drink it, and then they had to chew like 2 or 3 pieces of gum afterwards until the taste was out of their mouth. So we're pretty confident they didn't know what they were getting. And then we had them say, for true control, we said, well, we're going to have them swing off a tee, but we also want to know what it's like more in a dynamic situation, right? So we had them go off the machine. And then in the literature, there was some sort of, the effective window of caffeine is still trying to be well understood. And so we wanted to do 2 different time points, a 1-hour time point and a 2-hour time point. we utilize this little piece of equipment that is a really slick sort of piece of equipment. It's a commercially available accelerometer that hooks on the end of a bat, and then it gives you all these metrics about the swing of the individual. And we went to, again, we tried to go to great lengths to make sure that this was actually accurate. We called the company. They said they wouldn't give us their algorithm, but they could assure us that it was well tested, these types of things. And then we had the tee and we had the pitching machine. And what we found was really interesting. This is one of those things, I was like, let's do it right, let's set it up correctly, and let's see what we get, but I wasn't expecting a lot. What was really interesting is that overall, when you combine both 1 hour and 2 hour, we see that the average swing speed increased by about 3.38 miles per hour. So over here is in meters per second, because that's what the literature wants. This is more sort of easier for a lot of people to understand here in America. And so if you ask any softball, baseball player, they will take +3, almost 3.5 miles per hour to their swing speed. Also, it's always important with these types of things to not just say, well, this is the average, because we see there's some variability within the average. And we were analyzing a lot of swings. It was 10 swings from a tee, 10 swings on a machine at 1 hour and 2 hours under 2 different conditions. It's a lot of swings. But it gave us the kind of statistical power that we needed to try and understand if there was an effect here. So what we found when we look at the average in the placebo versus the caffeine condition in both, at both 1 hour and 2 hour, we see basically 9 out of 10 subjects and one that kind of, I guess you could argue went down, but really just remained flat. So we had one that was a non-responder, which is not uncommon when you're working with complex biological systems and a lot of heterogeneous population. But 9 out of 10 of them had improvement, which was fairly compelling. Off the machine, as expected, there was a little bit more variability, but overall still a trend towards the caffeine having increased effect on swing speed. So, and why I say not unexpected is because it's hard to account for different styles of swing, and we talked about this a lot. So if people like to wait longer and see the ball longer and then they swing faster, or they get out ahead of the ball, or they're hitting for contact, there's a lot more variables than just hitting off the tee. So this is kind of the true kind of control condition. Also, just wanted to share quickly, this is the 1 hour hitting off the tee and hitting off the machine. And again, we saw really similar data and similar. So even when we started to tease it out a little bit, and it wasn't the 1 hour and the 2 hour, we saw this. We saw similar at 2 hours, but it wasn't quite as robust, especially in the off the machine at 2 hours. So the next project that I kind of want to share with you is something that's completely different. And I just want to show kind of the breadth of what we've been able to do with the opportunities that we've had, and the colleagues and the help and the input and the students really specifically. So in 2016-17, we established a partnership with the Umatilla and Morrow County Head Start organization. This is the head office for UMCHS, and they have about 260 staff spread across, I think it's 20 sites all around kind of eastern Washington, southeast Washington, northeast Oregon, western Idaho, just all over this area and in Oregon. And so we were actually, I was at a event that was held here on campus by OHSU called the MORE Consortium that my colleague Kelly Rice McNeil helped kind of put together and facilitate here on campus. And a gentleman came from the Moore Institute, and a bunch of community partners came to campus to hear about some emerging sort of things in healthy nutrition and things that public workers and people that are working with people, particularly that are vulnerable, could better understand some aspects that maybe they didn't know about. And we were in a breakout session, and I ended up in the breakout session with the executive director of UMCHS and her staff. And we started talking about staff fitness and wellness and these types of initiatives. And this is a very sort of low, moderate pain, or even you could argue low pain for what they're doing job that is very high impact and very stressful. You're working with pre-kindergarten kids that are coming from underserved areas and their families, and it's just really difficult. And they wanted to kind of start thinking about investing in the wellness of their staff. And one of the things they were telling us was, well, we've now bought Fitbits for everybody at our staff, and every new hire gets it, and every one of our staff get one of these Fitbits, but we don't really know what to do with them or what to do with the data that's generated from them. And she said Fitbit wanted to charge them like 15 or 20 grand a year to maintain a database. I said, don't do that. We have Capstone students that need to do that, or that can do that. And I said, and this really was the start of a partnership. So I went, I've gone down there a couple times and given some talks. We got some students involved, and this is something, this is work that's ongoing, and it's something that students can be involved with year after year, and they can build on it and they can pass it off, and it's something that's turned into a pretty cool project. So in 2017, I had 3 Capstone students, Lexi Peter, Rachel Stone, and Emily Spears. They conducted what's called a needs assessment or a health and wellness survey, where we had 120, so almost 50% of the employees at UMCHS take this survey, and we found out that 80% of them express wanting to improve their physical self. The vast majority of them report having moderate to high stress. We also got some other pieces of information out of there, like how they deal with that stress, and we got some insight into kind of what they were doing to cope in these ways. We observed that less than a fifth of them were getting the recommended amount of physical activity, and they wanted to know more about health and wellness. They wanted that information. And the students, I put this up here because this is a really cool infographic that the students, I just said, how are we going to present this in a way that is relatable for them and that we can distribute widely? And they came up with this infographic, and it was very cool, and it just said a lot about kind of where the staff was at the time. And then it also says down here, stay tuned for weekly emails including fun health facts and activities. And this was kind of the start of our idea that now that we know what's going on here, how can we potentially make a positive impact in this in this environment? And they presented this at the yearly health fair and passed out these flyers and had a poster, their spring symposium poster down there that they presented, and it was a really cool opportunity for them. So fast forward then to January 2018, there was an opportunity that was put out to all Head Start communities, or all Head Start organizations across the country, to put in grants or proposals to be invited to a 4-day workshop at UCLA, the Anderson School of Management, where they were going to take a select number of Head Start organizations around the country and train them on how to kind of assess and implement staff health improvement programs. And if you got the award and were invited to go to UCLA, then each organization could choose one community partner to come along with them. And that was funded through Johnson & Johnson. And so I got the opportunity to go with UMCHS. They got the grant, they invited me to come, and this was a really great workshop. There were a lot of speakers, a lot of academics, and a lot of different areas. We learned a lot, and really we were able to work and synthesize up the idea of, we have some information which was actually ahead of where a lot of other organizations were because of the work we had done the previous year, how are we going to implement it in a way that is hopefully effective? So out of that brainstorming session, as well as with input of two senior students last year, Amy Arnzen and Khadijah Newmeyer, we formed a pilot program called the Kickstart for Head Start Digest. So this was an 8-week program where we were going to send out a weekly newsletters that the students were going to make and deliver, and then manage email accounts and feedback, and really try and get the people at UMCHS excited about doing things that were positive for their health. So we based our topics off of things that we collected data on the previous year in terms of what people wanted to know more about. And so this is an example. This was the cover of our digest. We would send it out in a PDF sort of ebook every week. We would talk about a particular topic like mindfulness or nutrition. And then this is really an important part of the program, was that each week we provided them with a specific and what we thought was achievable action item. So here's one where just think about this traffic light approach when you're at the grocery store, right? Think about assessing what's in your grocery cart this week. Or try and do these things like unplug your phone before you go to bed at night. Try and take care of things that you wake up worrying about before you go to sleep. These types of things that are based on the literature, but really because it was driven by the students, were presented in a way that was, you could communicate it across a broad population. So we also made sure to celebrate success each week. So they did an awesome job with this. They would do these shout outs, and people would send us pictures of them hiking or doing 5Ks, and we would try and make sure to do that. So this is one from April 11th. The students had started a Fitbit group and encouraged people to join it. And they were talking about the progress that had been made so far during that month in terms of miles walked and steps taken and those sorts of things. So in regards to how the response to this Kickstart for Head Start Digest, we had a bit fewer responses. We have a difficult time getting the survey out last spring, but we still got about 25% of the employees. And what we'd like to see is sort of, on these questions about how would you rate the information overall, we were happy that the majority of people were kind of at this end of the spectrum, but I'd like to have more people going from, instead of being the majority in the 3, have them at the 4 and 5. And so I don't know if that's a matter of just continuation. It was only an 8-week program or those sorts of things. So if anybody has any ideas, I'd be happy to hear them. So how would you rate the topics in terms of being appealing, similar data, how relevant was it? But this is the one that I really, that I thought was quite interesting. Will you use the information and the exercises, the health and exercise sciences information that was provided in the digest? And only 9% of the people just flat out said no. And it's this orange pie that we'd like to move into the blue area this year. So people in the trans-theoretical model of behavior change, people are now, they're thinking about it, and we're gonna try and influence this year their preparation and action towards it and see if we can track that in some way. So yeah, I wanna give a really special thank you to the students that started that program, the 2 students, Khadijah and Amy, that did the newsletter every week for 8 straight weeks and did that data and presented their work down at the Head Start Health Day. And here are new students this year that are going to kind of implement it throughout the year, more than just that 8 weeks, and see if we can have an effect. Okay. This is the next project I want to present, and I want everybody to watch this.
I'm interested a lot in like injury rehabilitation, etc. And so I just was trying to see where people fell off or just who wasn't responding. It's a comprehensive evaluation of its sports team here, which has never been done before, and I think it could give like a good baseline for exercise science students to collaborate with sports teams here. So hopefully this will give just a a baseline for optimizing performance recovery throughout any team here at EOU. So a lot of these testing I've had exposure to in like my exercise science classes and kind of exposure to using them. They're all kind of associated with decreasing performance. So we're kind of just seeing where that person is able to go, how far they're able to go for how long, and when we start to see decreased performance because of these physiological responses. But I think in the end it's going to be a really cool analysis of at least the 15 girls that I'm following through this, and hopefully give them some insight of how to increase their performance and they can use it later on. Coaches a lot of the time think it's mental toughness that individuals that are trying to build, and that's why volumes of training are so high. But in reality, like, your body can only sustain so much load for so long before it'll give out, and we've been always taught to push through that and find a way. But if we could maybe reel it back in on these athletes when we start to see decreased like performance, so that way overall we could optimize their training and optimize their performance like later on in spring season when they start games. My major is physical activity and health with a concentration in exercise science, and using all of this equipment I can put down on a resume saying that I know how to run these sophisticated VO2 max tests, a lactate threshold. I've done it 30 times on 30 subjects, and so I think that'll aid me. At least it's more applicable to the physical activity and health side of things. I mean, it's something that I've had a background with and struggled with injury throughout my 4 years of playing, and it's something that really interested me, was just to see if I could help them in the future. Being a student athlete here was amazing. It was coming from a community college in Seattle. It was really big and there was no close connection with the athletes, and here I just feel like you know everybody kind of says hi to you in the hallway, and usually teams go out to support each other, and I think that's a really important part of the athletics here at EOU. My name is Madison Oxford, and I am a women's soccer student athlete here at Eastern Oregon University.
Okay, so I think Maddie did a great job of explaining what that project was about. We were trying to find out if you take one program and apply it to everybody, does everybody get a benefit from that? And when we examined their VO2 max, which is an important measure of physical fitness that year that we did this, first thing you see is a lot of different starting points, so a lot of different types of athletes. This could be due to position type, genetics, training, all different types of things. And one of the things that we saw is not everybody, particularly some of the people that scored higher on their VO2, got a benefit from sort of a one-size-fits-all training approach that winter. Others did. And so you have different athletes, and you apply one program, you get different results. Last year, we had 3 new students that were on the soccer team: Anna Roslander, Bobby Pendleton, and Natalie Mitchell take over this project. And we really got a lot of buy-in from the top down. The coach was on board. The students were really into it. The whole team participated this year instead of a subsection. And what happened is, after the initial assessment for strength and cardiovascular fitness and all these different types of things, we were able to make specific training groups. The students did this. They identified specific training groups in specific areas that different people needed to work on the same. And this is just one example where every one of them had some sort of benefit in their VO2 last year. So again, this is one of those examples of another project that can go on year after year. Students can plug into it. We add equipment to the lab that can increase our understanding of this. It can be added to databases of information about the players and the success or variability in training responses to this particular program or that particular program. And the most important thing in regards to this is that if a lot of the students that get involved with these want to be coaches, they want to go to, say, the MAT program and then coach. And this is a separator when you can kind of show you have this performance tracking system that you've developed and you know how to do, and that kind of makes you sensitive to the individuality of your players. So the last project that I'll quickly kind of present, because I'm really excited about this one, is this partnership that we started with the Grand Ron Repellers, which is a local team of elite firefighters. They would probably get embarrassed by me calling them elite, but that's what they are. These are men and women that are involved in what's called initial attack. So there's a lightning strike in the Eagle Caps. Nobody can get to it. Before that fire gets out of control, they fly helicopters there and then jump out of those helicopters on 250-foot ropes, zip down into the fire, contain the fire for anywhere from 1 to 4 days, and then they take all their chainsaws and equipment and everything and hike out. And this is a very physically demanding job. And the assistant rappel foreman, a gentleman named Kyle Johnson, is out at the airport. He wrote me an email one day, and he said, he explained who he was, and he said, I've created this packet because for rookies coming in that don't really have an understanding of what they're going to go through, because there's a disconnect in what the government requires in terms of a physical fitness test passing and what the realities, the physical demands of this job are. And I want to give these rookies a better chance of making it through a season successfully without injury, things like that. It took me about 5 seconds to get to my phone and call that guy on the phone and say, instead of me just going through this packet and like saying to you what's right and what's wrong, let's start a partnership. Get your firefighters into our lab. We'll get students testing them for their VO2 max and their strength. We'll track them over time, and we'll find out what they can do in the off season and during the season to try and maintain. And it started this really unique round of just discussions about what they go through and what they know they go through, but there was really not a lot of data to really demonstrate what they actually go through. So we created this model. I'm not going to go through it all. This is what my dream of this would someday be, that we're creating this we're creating this way of tracking, optimizing, and utilizing a lot of different resources in a lot of different departments to contribute to this project throughout the entire year to create a longitudinal database of ongoing analysis to inform what I call systematic changes in how they go about preparing and making it through these seasons. So really, as far as we've gotten so far is really this. We've done some performance evaluations, and tomorrow, actually, we're going to have firefighters coming in and out of the lab for over 6 hours getting postseason performance testing so we can look at the difference between their preseason values and their postseason values. This will be the second year that we have that, and so the first year we have it is for the 2017 fire data. What we found was pretty interesting. From a aggregate standpoint, average VO2 went up. Not surprising, they're very, very active all summer. What was a little bit more surprising was that all of their indicators of strength went down, which would suggest that they're getting cardiovascularly fit, but the long hours and the type of work that they're putting in was degrading their muscular strength. That's the way we took it. And so, and the way we've described it is, and they kind of told us as much anecdotally, that they spend the entire off season trying to get back to zero. And as some of these men and women age, that becomes a lot more difficult. They're like elite athletes, right? And so what we're trying to do is we want to try and implement strategies that can help them maintain throughout the year so that they can add to their quiver in the off season, not just spend their off season recovering and getting back to normal. And that's kind of the model now in professional athletes. We're seeing professional athletes with much longer careers, and we're trying to apply that here in a similar way, and they're excited about that. So the other thing is, and I won't go into this too much, but these are the 9 firefighters that we tested in the initial round. This is the effects of the 2017 season. Some of them, about half of them, gained weight during the season. All right. Their VO2 maxes went up, which is what we saw in the aggregate data. Their body fat percentage in a lot of them also went up, which is really interesting, right? So it demonstrates that you can't outrun a bad diet. if you're just eating for calories' sake, just because you're working a lot doesn't mean it's going to be able to fuel you and kind of take care of you the way that it should be. Their predicted maxes went down, some very substantially. Predicted squats went down, and their predicted deadlifts also went down. We want to try and be able to see, can we put new foods in their food boxes that can, or can we give them maintenance training protocols that they can do in season? And Alyssa Cohen, my former colleague here in the exercise science department, she was instrumental in helping us find non-weight dependent exercises that people could do in season to try and maintain some of this. So the 3 students that really got this going were Jamie Butler, Peter Kane, and Taylor Walden. They actually started the spring of their junior year planning to carry this project over into their senior year for their senior capstone. That's why we had the preseason 2017 data and the postseason, the spring and fall data. And then tomorrow, these students are collecting the post data for the 2018 season. So that's the last thing I was going to talk about. I'm kind of on time. I don't want to skip the acknowledgments, but I'll go through them really quickly. These are the funding agencies that helped me out during my training. Since I've been here, we've received support from UMCHS as well as Grand Ron Repellers. And I also want to talk about this cool little tool that we have called the EOU Sharing the Learning Grant, which is something I found buried in the depths of the FDFC committee page when I was here for my first year. You know, when you need $200 worth of Red Bull to run a study, you can have your student write a grant for that, and that's actually supported. That's been a really important part of getting some things that we needed to do this. I want to specifically thank the students that were part of the projects that I presented here, but I also want to just talk about the overall impact that these types of programs have had on student success. And so this is a list of students that have gotten into graduate school that I've directly worked with over the last 4 years since I've been here at EOU. And I just want to point out that, you know, we have doctors of naturopath, clinical laboratory scientists, MAT program, athletic training, nursing. But I also want to draw special attention to the number of students that have gotten into physical therapy school. Physical therapy school, last year there were 118,620 applications and 9,900 seats. That's 12 applications for each one seat. And we've had 7 students in the last couple of years leave our department and go to physical therapy programs. So with that, yeah, I'll take any questions.
So I'm new here, obviously, but you've talked about a lot of great human subjects research that seems like it would be disseminated outside of the classroom. I haven't heard any talk about an institutional review board or anyone refereeing human subject research. Sure. How is that handled?
We have an IRB. I'm on it. Charles Lyons is the head of the IRB. And we have a community representative, we have people, we have faculty and non-faculty. The idea with an IRB, right, is that everything that you do that involves human subjects, you present to the IRB, and you want the members of the IRB to be outside, not interested in the research you're trying to find, because that could be like, yeah, do that, because I want to know what's going to happen, right? So you want to take people that, or you want to have people that are from a really broad range, and then they discuss really critically those issues. So every single one of the studies that we've presented was approved by the IRB here at EOU. And it's actually one of the things that I always tell students to make sure when they're in their PT school interviews or grad school interviews to say, look, this wasn't just a research project that was somebody else's idea that I plugged into. I wrote the IRB. Yeah, there's revision and supervision and those types of things. And I know the number of those IRBs that come through every year because I'm reviewing them. The psychology students, it's really cool, the number of interesting projects that students are pursuing. So, yeah.
We have about 2 more minutes if somebody has another question.
Sorry, it took up a bunch of time. Did you have a question, Tony? Oh, yeah.
Oh,
Yeah.
sorry.
Hi, Kyle.
Hi.
I'm fascinated by the variety of projects, and I wonder how you juggle. It looks like students are working, like you're supervising students working on multiple different projects at the same time. How do you do that?
So this is a really good question. So one, I try not to say no initially if it's something that kind of makes me feel uncomfortable or is outside of my comfort zone, because if there's one thing I learned, going back to my training, it's that you can be broad and thorough across a variety of fields. And I took away a lot, so I was basically studying nutrition biochemistry, but I was in Ph.D. seminars with people that were studying a wide variety of things within nutrition. And so I kind of have heard of a lot of these things, and I sort of know where to look. I also rely on colleagues, both present and past. Kelly and Darren have been invaluable in helping me really tease out a lot of these things and say, I mean, that staff wellness program is much more in line with Kelly's expertise than mine. That's one of those things where you just say yes, and then you just figure you could figure it out once you start to get going on it. But without Kelly giving me little nudge here, nudge there to keep me on the path, she looks over our surveys. She does, so it's that type of support. The other thing is I really do rely on the students. I say, look, if you're interested in this and you want to do this, here's what you do. But we just went through it this year. I said, we need a new survey this year. In a week, let's have a meeting. Present to me what you found about validated surveys that we can use to try and see where people are changing. And then we had a critical discussion about it. So it's really, I don't know, just try and pursue those things and be creative. Yeah.
Well, thank you so much. We are out of time, but Kyle has a few moments to kind of sit and hang out if people need to ask questions.
No problem.
But for those of you who need to leave at 5, it's certainly time. So thank you, and thank you, Kyle.
Yeah.